This is a very bleak explanation on how orthogonal array works, but we will go over some properties of an orthogonal array. Okay. For instance, this is a L4 and this is an L8. What is the meaning? There will be 4 experiments, there will be 8 experiments. In an orthogonal array, the elements between any 2 columns are balanced and within a column they are balanced. We will see what it means. You take this is, let us for discussion purpose we will make it A, B and C, factors A, B and C, level 1 of A, level 1 of A, level 2 of A, level 2 of A. So, is the case level 1 of C, level 2 of C, level 2 of C, level 1 of C. So, if you take A 2 level 1s, 2 level 2s, you take any of the column, it will be balanced. Or if you take any of the 2 columns, if you see 1 1 together, you cannot see another 1 1 within this 4. So, any other combination also will come only once, it will not repeat. 2 and 2, you cannot see another 2 2. 2 and 1, you cannot see another 2 and 1. This holds good between any of these columns A C, B C, A B, anything it will hold good. Now, let us go to L8, let us see whether it is true. I have helped to, you can take column number 3, take column number 3, 1, 2, 3, 4, 4 1s, 4 2s, the column is balanced. Take column number 6, 1, 2, 3, 4, 4 1s, 4 2s. So, the levels are balanced within the column, any particular column. Now, you take any 2 columns, column 3 and column 6, or we will take 2 columns right next to each other, it is easy, and then we will go to 3 and 6. One 1 happening twice. You can see the rest of the stuff, there is no 1 1. If a combination is happening twice, any other combination will also happen twice, nothing less, nothing more. We will see 2 1, 2 1 is also happening twice, there is no other 2 1, 1 2 1 2, 2 2 2 2. You can do this for any other column also. So, now let us do between 3 and 6, 1 1, 1 1 happening twice, 1 2, 1 2, no other 1 2 will be there. So, there is a reason. The columns within a column, the levels are balanced, between any 2 columns the levels are balanced. Does this give some information to you? What did we discuss about levels? Not all levels are there, they are fixed in some levels, they are not fixed in some levels.
So, like we did that for the full factorial one, where we did 4 experiments, A1, B1, C1, A1, B2, C1, let's say. So
that is not a full factorial, that is one factor at a time,
one factor.
multiple factors at a time. Yeah.
So, we were losing information on the second level.
Exactly. So, what you are actually doing there is, you have a bias on B and C's first level. So, you are fixing it there. That does not happen here. The beauty of this one is this L4 can be derived from L8. There is another stuff, right. How can you do that? Because this seems, that is the reason that they have 1, 2, 3, 4 instead of alphabets. For A, B, C you can write it like that, but what will be the column headings for this L8? You understand the question? And there is also a relationship, number of experiment versus the number of columns. It is n minus 1. If you have 4 experiments, you will have 3 columns. If you have 8 experiments, you will have 7 columns. Okay. Now, what is the difference between L4 and L8 you think? Of course, the number of experiments, but in terms of the factors and can you imagine? Okay. Here is a question for you. Okay. 8 experiments means what? 2 raised to 3. This could be a full factorial experiment. Now, if it is 2 raised to 3, I have 3 factors A, B and C, each of them at 2 levels 1, 2, 1, 2 and 1, 2. Now, tell me what are these columns? Sorry? Tell me, assign the factors to the columns. You are having only 3 factors, right? But you have 7 columns to assign. You get the question? The standalone factors are 3, but how many are there? 1, 2, 3, 4, 5, 6, 7. This is a full factor. This is another way of looking at it. If I am reducing this from L8 to L4, what am I going to compromise? I am happy with the fact that I do not have to run 8 experiments, I have to run only 4 experiments, but where is my information lost? I cannot account for these guys, I can only account for A, B and C. You get it? In a similar fashion, if you have 2 raised to 4 factors, you have A, B, C and D, 16, full factorial is 16. You can bring it down to L8, you will lose the 3 factors, okay, because there it will be ABC, ABD, BCD, you will lose those. Can you bring it down to L4? Sorry? Yeah, see, from L8 to L4 itself your interactions are lost. So, from L16 to L4 for sure your interactions will be lost, but my question is 2 raised to 4 means there are 4 factors. So, can you reduce L16 to L4? Ah, AB, BC and CD. What about AD? What about BD? So, then you are biasing, that is the whole point, you cannot bias. Okay. So, there is an order in which you will knock things down, okay. You cannot just knock things down just like that. Okay. So, for example, you have A, B, C and D. So, AB, AC, AD, BC, BD, CD, ABC, ABD, ACD, BCD, ABCD. So, that will give you 16, 4, 7, 10, 14, 16, 15. Correct. 16 experiments, 15 factors. Okay. So, when I am going from this is L16, when I am going from L16 to L8, the way in which I will proceed to knock down is this. I will first knock down this guy, then I will knock down 3 factor guys 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still it is not okay, correct, because if it is L8 I have how many columns? So, I can accommodate only 7, but I have A B C D, A B A C A D, B C B D C D. Now, what will I do? That is some order that I wrote. You have no idea which one is more sensitive. So, there is something called confounding. So, what you do is you couple 2 guys. There is a reason, there is a way in which you can couple. I am just drawing something here. Okay. Now, what happens is you assign one particular column to A, B and AC. Later we will see when we analyze and all that, you will identify that column number 5 is very sensitive, but in that case column number 5 could be AB or AC, you do not know. If column number 5 turns out to be effective, then you will have to do additional experiments to understand whether it is AB or AC. Okay. So, this is called confounding. Anyway, so I guess you got the idea of the property of an orthogonal array. So, tomorrow someone shows you an orthogonal array, you know whether it is an orthogonal array or not, because you just need to look at whether they are balanced. Okay. So, we are just trying to do a result analysis here. We take the same kind of an experiment and then we say A factor ABC, there are 2 levels, it is all balanced, it is an orthogonal array, and these are my results. Now, there is an interesting question. In the previous one, in the previous case that we discussed, for identifying the the effect of A, there are only 2 rows. In one row it was A1 and in the other row it was A2. So, I went ahead and subtracted. But in this case how will you do that? Because there are 2 rows with level 1 and there are 2 rows with level 2. Which one will you choose? You get the question? With this data, I want to know the effect of A. How will I do that? So, you have B1 and C1, then you have B2 and C2, but for both of them it is A level is 1. Then for some other random change A level is 2. The difference between the previous one and this one is, there you had only one row where A had level 2, but in this you have 2 rows in which A had level 2 and you have 2 rows in which A have level 1, and your B and C are not held the same, they are changing. If you take these 2 rows or any 2 row, 1 1 never repeats. So, you cannot bring that argument. B and C is the same, so I will compare those 2, and actually that is exactly what we wanted. What have we said? So, one way to look at this is, the moment you have more than 1, what do? We have talked about averaging and standard deviation. So, what you do is this, you average the value for these guys. So, that becomes my A 1 and I average these two guys, they become A 2. Now, you do not worry about what your values of B and C are, because that was our limitation in the previous one. How can I not worry about it? Boss, you do not need to worry, because you are looking at an orthogonal array and it is already balanced. You understand? You are not biasing on one side. You are not biasing on one side. Can I do the same average in that previous one? Yes, you can, but you are biasing. You understand what I am saying? There were 3 A1s and only 1 A2. There were 3 B1s and only 1 B2. There were 3 C1s and only 1 C2. So, the way in which you conducted your experiment, you have already biased it. You had a favorism for A1, B1 and C1, but that is not the case here. So, number 1, the balance that we spoke about in terms of the columns and between the columns has a meaning. You are not biasing on particular level, and you are not fixing the other two factors also, they are taking the different combinations. So, what you need to do is this, we will call this A1 bar and A2 bar, and then if you take the difference between them, it will be the effect of A and B, A. Similarly, if you want to do for B, what will you do? You will take the responses corresponding to this and this, you will take an average, you will take these two responses, you will take an average and subtract it. Okay. Now, in terms of using the information, what do you see the difference between that previous approach and this approach? There, how many experiments did you conduct? 4. Here, in computing the effect of A, how many experiments value are you taking here? There for effect of B, how many experiments are you taking? Okay. So, you are getting or you are using more information to find the effect of A. Otherwise, you are doing 4 experiments there and you are using only 2 experiments to get the effect. Here you are using 4 experiments and you are doing 4 experiments and you are using all the 4 experiments to get the effect. That is an advantage. There, if you plan to do that, it will be wrong, because you will bias. You can say, sir, if you are averaging here, there also I will average. If you average, it is not correct, because it is B1 is appearing 3 times and B2 is appearing only once, and necessarily your A and C, they are not changing also in a uniform fashion, they are not staying the same also. So, it is not the correct way to do that there. Okay. This is what that discussion is. L4 is not any different from the 3 2-level factor experiment using the one factor at a time, then why use orthogonal array. So, this is that experiment. So, if you see here, we have 3 ones. Okay. Influence of A is but no information on what happens when B and C take level 2. But for an orthogonal based array based study, we saw how an average effect is computed for a factor. So, OA accounts for the interaction, that is important, and we saw how that interaction is taken into account. So, here is a plastic molding experiment. So, what is the quality characteristic? Is the tensile strength, but what kind of a quality characteristic is this? What type? What type quality characteristic? Larger the better, there is no more, larger the better. Okay. So, I want to find a combination in which I get the maximum strength. What are the factors? The temperature, the pressure, the time and the additive, and there are some levels that are given here, A0, A1, B0, B1. So, here is the deal, 2 levels, 4 factors. So, totally how many combinations for a full factorial? 2 raised to 4 is 16. in this case, whoever is doing this experiment, my interest is only in the AB interaction, okay, meaning A, B, C, D and AB, that should be only 5. So, I am only interested in the AB interaction, not in other interaction. So, you need to have prior information to make such a conclusion, otherwise you are biasing. In terms of the columns, I have A, B, C, D, A cross B, that is all I have, only 5. For an L4, which is the minimal, how many do I have columns? So, I cannot use, I need at least 5. The next possible is L8, there is no L6 or anything. Okay. So, L8, because it has to be reduced, I will show you how the reduction also happens. Okay. From L8 to from L4 to L8 we go, but in L8 how many columns you have? 7 columns, but I have only 5, I need only 5. So, there will be 2 columns will be designated as dummy. Do not worry, we will discuss in the next class on how this is assigned. For right now, do not worry about that. This is an L8. Whoever you are, whatever work you are doing, this is L8. I am a computer scientist. I am planning to do some kind of an optimal scheduling problem, I am using orthogonal array. For you also L8 is this. I am a manufacturing engineer. I am trying to understand the effect of manufacturing parameters on the surface finish. For you also this is an L8. I am an aerospace engineer. I am looking at different parameters on my wing and tail and fuselage to understand the flight time. For you also this is an L8. So, please understand the L8 that is prepared is available across the board for everyone, that so it is fixed. But what as a computer science engineer, as a mechanical engineer, as an aerospace engineer that you need to decide is what are the factors that are assigned to these columns. Okay. There is something called triangular tables and linear graphs that let you assign that. I will discuss that, that is not a problem. Okay. So, now, but we will just discuss quickly. Experiment number 1, this is the experimental condition. What does this mean? A, okay, that is because he, okay, let me just quickly tell you what a linear graph is. So, if you go to the back of any orthogonal array book, you will have these orthogonal arrays and there will be these linear graphs that are provided along with them. For L8, this is one linear graph. So, it will be said 1, 2, 3, 4, 5, 6, 7. This is how it would be given. There might be another thing. I am not sure whether the numbers are right, but this is how it works. Okay. What this means is these tables, the linear graphs are given with the table. You need to now assign what factor goes to what column. How you do this? You say A goes to this particular I assign A to 1, you assign B to 2, you assign C to then your 4, 5, 6 are frozen. What is my 5? A cross B. What is my 6? A cross C. What is my 4? B cross C. I am not sure whether that is correct, meaning this is how you analyze the table. The numbers are correct or not, I do not know, that we will figure out. A 1, B 2. Yeah, so this should be 3 actually. So sorry. So this is 4. This is probably AC means this is 5. Yeah. So if you look at this, A, B, the third column is A cross B, okay, the third column is A cross B, that is what is written here also, A cross B. The fourth we have assigned for C. In this case we are not worried, in case we have to complete this C, then 5 is A cross C, then 6 is B cross C, 7 I am going to assign D. Please understand, you cannot sacrifice A, B, C and D without sacrificing A, B, A, C, B, C, correct. So, this can be for 4 variables, or this can also be A, B, C. This could have been, if I am not considering D, this could have been A, B, C. You get the point? But you go with the linear table, but this enough work has been done to come up with the linear tables. What could be the other way? It could be this one, A, B, then I think this will be 3. Yeah, it cannot be like this, I am sorry. This should be 3, this will become 4, 5, 6, 7. This is only for discussion purpose, okay. This is for all said and done, this might not be correct also, but the process is correct. The graph itself might be wrong, but the process is correct. So, if I provide if I give A for this guy, B for this guy, then A, B is in 3, C, D. Now, I have 2 factor interactions, 4 of them, A, B, A, C, A, D, anything with respect to A I have, B, C, B, D I will not have, and you need not assign only A to 1, you could have assigned B to 1, you could have assigned C to 1, that is not a problem, but this is what the linear table is. Okay. There is something called a triangular table which we will see. Okay. Anyway, this is the idea to tell you like what is the factor. We will see what this means. So, all of them are 0 if you take the first row, okay, which means it is level 0. So, A is 0, B is 0, C is 0, D is 0. If you take this particular column, this particular row, it says C1 and D1. There is no physical meaning for AC and BC having 1, because there is only a, this is just an interaction, okay. You can only fix the factors, not the interactions. The factors are only for the levels are only for the factors. So, if the level of my A is 0 and the level of my B is 0, level of AB is automatically 0. If level of A was 0 and level of 1 was level of B was 1, then A cross B level is 1, that is what you will see here. Okay. So, there is no physical meaning for A cross B 1 or A cross B 0, it comes from what levels A and B take, there is no physical meaning for that, whereas there is a physical meaning for A taking level 0 or level 1. Okay. So, you conduct all these experiments, there are 8 different setups, 8 different values you get. Now, there are 2 things that you can do. What can you do? You can find the statistics. What was the objective of our problem in this problem? What was the objective in our problem? In this problem? What was our objective in this problem? You forgot what the problem, what was the problem?
Model the tensile strength as the combination of A and B.
No, that and all was not the objective. The objective was to maximize your tensile strength, that is all. Okay. So, the point is simple, I have given you a bunch of data. So, what you do is you look for the maximum strength. Which is the maximum strength in this? So, you can say okay, you will get the maximum strength at this combination if you run this experiment. Is that right? Yes or no? This is just statistics. In the given condition, yes, okay, but you should also remember that this is not a full factorial experiment. So, there could be some combination that you did not try could lead to a better result. So, how do we analyze that? We will discuss in the next class. Okay? Fine, thank you.